Okay, dealing in section 4.8, we first need to introduce ourselves to what's called the imaginary unit. Okay, it is the imaginary number. It's the one thing in math where somebody somewhere had to just come up with this idea and then we can run with it from there. Okay, and that idea is the imaginary unit, which is that I equals the square root of negative 1. Because remember, we can't take the square root of negative numbers, right? Or at least not with real numbers. We can't get an answer for that. And so up to this point, we've always said, well, we just have no real solutions. That's why we had to have that real part in there. There are solutions, but there weren't real solutions. Because now we can take square roots of negative numbers if we use the imaginary unit, or I. Something else to keep in mind is that I squared equals negative 1. Okay? I is the square root of negative 1. I squared equals negative 1. Okay? So here's a very good example of what's going on here. Is if we have the square root of negative a, then we could factor that into the square root of negative 1 times the square root of a. And then, well, the square root of negative 1 is I. And so we have I times whatever the square root of a is. Okay? So I is the imaginary unit. I equals the square root of negative 1. Okay, so how are we going to use this? Well, let's take a look at our examples here, simplifying numbers using I. So, how do we write the square root of negative 18 using the imaginary unit I? First things first, we could do this just by factoring like we've always done. So we could say that we've got the square root of negative 1 times, well, now the square root of 18. What does the square root of 18 break into? What perfect square goes into 18? 9. Yeah, so we have the square root of 9 times the square root of 2. So, we just said it. What is the square root of negative 1? I. So we got I. The square root of 9 is 3. And the square root of 2? Square root of 2. Just, yeah, it stays square root of 2. So now here we got to talk about a couple of things. First off, the order in which we write stuff makes a difference. There is a standard way of doing this. Okay, it's kind of like when we have 3x, we write 3, then the variable. Okay, we don't write x3, we write 3x. Same thing goes with imaginary numbers. The constant term, the 3, always gets written first. Okay, that's a horrible looking 3. All right, the constant term always gets written first. Meh, that's better. So, next would come the variables. Okay, if we had variables, x's and y's and things, we'd put those next. Okay, but in this case, we don't have a variable, but we do have an I. So we're going to put I in here. And then last comes any radicals we have. Those always go on the end. Okay? So the proper way of writing this answer would be 3i square root of 2. All right? Questions? That's it. That's reducing the square root of negative 18. 3i square root of 2. Everything is exactly the same, except we have to pull an I out. Okay? Yes, sir?
Where you can get this negative 1 square root?
All right. Any other questions there? Well, then I want you guys to simplify the square root of negative 12. Okay, so what are we getting here?
3.
Well, you should be breaking into the square root of negative 1 times the square root of 4 times the square root of 3. Yes? Yes. If you weren't, you are now. Okay. What's the square root of 2? What's the square root of 4? 2. Okay. And what's the square root of negative 1? I. So we get 2i square root 3. Okay. Now, notice in all of these, we've been factoring out the square root of negative 1. And yes, that's always what you should be doing, but there's kind of a shortcut. And the shortcut, in my opinion, is just to pull an I out. Okay. Besides that, I just like saying pull an I out. Okay. So, if we have the square root of negative 25, step 1, pull an I out. That's just I square root 25. And what's the square root of 25? 5. So the answer is 5i. Questions? No. How about the square root of negative 7? What can we do there? Oh, we leave it like that? We've got to pull an I out. There's a negative under the radical. Pull an I out. So we have I square root of 7. Okay? Questions? Last thing I want to talk about is the difference here on the bottom. Explain why the square root of negative 64 is not equal to negative square root of 64. What do you guys think? Okay, well, first off, yeah, what's happening here? What type of number is this? It's going to be imaginary because we have a negative inside the radical, so we can take an I out. So we have I square root of 64, and what's the square root of 64? 8. So therefore this is 8i. And for negative square root of 64, that negative is not involved in the problem yet, right? That means that we've got negative whatever the square root of 64 is, which is 8. Okay? These are not the same thing, obviously. But furthermore, 8i, that's an imaginary number. Negative 8, that's a real number. Okay? So they're very different numbers. You got to watch out because they look very similar. Again, that's that attention to detail. A lot of people in here aren't paying close attention to your negatives. You have to because they mean very different things depending on where they're written. Okay? All right, one more real quick and then we'll move on to what else we're doing today. So number 2 down there, we want the square root of negative 144. What do we do first? Pull an I out. First we pull an I out. Well then what's the square root of 144? 12. So the answer is 12i. The other thing that I would suggest to you guys is when you make eyes, all right, put a little tail on your eye. Okay? Because a lot of people, have very nice handwriting and everything, and they, make nice little eyes. But as you start working a problem, as you start writing things faster, as you get nervous on a test, that 12i suddenly starts looking like 121. Okay? So watch out for that. Am I going to count it wrong if you don't put tails on your eyes? No. But trust me, follow my lead here, okay? It's going to help you out. That's also why you guys see mathematicians or just math teachers in general, when we draw T's or write T's in a problem, we don't say 5T. We say 5T. We put a little tail on it because that way it doesn't look like a plus sign. Okay? So that's the whole idea there.
Or Z's with the line through.
Yeah, exactly. I do Z's with the line through so they don't look like my 2's. But yes, all those things. All right? So I put a little tail on it. That way you don't get it mistaken with a 1. All right? Okay, so the next thing we're doing today is kind of an extension of that. We're talking about complex numbers. Okay? Complex numbers have 2 parts. They have a real part and an imaginary part. Okay? And they're put together with addition. We're taking a real number and we're adding an imaginary part to it. Okay? If all you have is the imaginary part, like all the answers we've dealt with so far, okay, everything we've done so far in this class period have all been pure imaginary numbers because there is no real portion to them. Okay? But now we're going to be dealing with complex numbers, which again, like I said, has a real number and then we're going to add or subtract an imaginary number. When you have that, it's called a complex number. So, to add or subtract complex numbers, I have a nice little paragraph here explaining it. Basically, it says we combine the real parts and we combine the imaginary parts. That's then how we combine complex numbers. The nice thing for you is that it's not any different than anything you've done before. If you think of I like an X and treat it that way, for the most part, you're going to be right. Okay? For the most part, you're going to be right. So let's take a look here at number 4. Number 4 here, we have a complex number plus another complex number. Okay? Do these parentheses here do anything for us? I mean, do we have multiplication we got to deal with? Do we have any kind of distributive property we got to deal with? No, they don't do anything for us. How about these parentheses here? No, they don't do anything for us. The reason they're there is so that we can see from the beginning that, oh, complex number plus complex number. That's why we have the parentheses there to start with. But to work the problem, we don't need them, so I'm going to get rid of them. Negative 2 plus 3i plus 5 minus 2i. And now we just need to identify the real part and the imaginary part. So what are the real parts here? Which parts here are real numbers?
Negative 2 and 5.
Negative 2 and positive 5. Which parts are imaginary numbers? 3i, negative 2i. And so, just like you would combine like terms, we combine these parts. Negative 2 plus 5? 3. 3i minus 2i? Plus 1i. There's our answer. Questions? Sure.
Where's the equal line on it? And just normal equal sign.
Where's the equal sign?
No, there's a equal and equal line.
Oh,
It's different.
okay. Back from that previous problem that we had.
Yeah.
The difference is, that's kind of aside from this. But yes, if you have, where am I going to put that? Right here. That means equals. This means not equals. Equal to, not equal to. That's the difference there. Okay? Yes, ma'am. How did I get the 3 out front here? Because I took negative 2 plus 5.
And that's it.
Yeah. Negative 2 plus 5. If you look at a number line, here's 0. I go back here to negative 2. If I want to add 5 to that, adding is going in the positive direction. So I go 1, 2, 3, 4, 5, which is at positive 3. Yep, negative 2 plus 5, positive 3. Any other questions? Let's try another one. Number 5 here. Looking at that first complex number, do these parentheses do anything for us? There's nothing going on outside those, so no. I'm just going to get rid of them. 4 minus 2i. But now look at the second set. Do those do anything for us? Yes, because we have a negative out in front. We are subtracting that complex number, the whole thing. That implies that we need to distribute that negative through. So we no longer have minus 1, it's plus 1. We no longer have plus 3i, it's minus 3i. Okay? So, 4 plus 1 is 5. Negative 2i minus 3i. Negative 5i. Questions? No? All right. Another one. Look at number 7. Looking at number 7. First set of parentheses. Are they doing anything for us? No. All right, so I can get rid of those. So I've got negative 2. Oops. Negative 2 plus the square root of negative 9. Look at the second set of parentheses. Do they do anything? We have no distributive property, no nothing like that, so no. So I'm just going to get rid of that. So minus 1 minus the square root of negative 36. Okay, well, I can combine negative 2 and negative 1, but can I combine square root of negative 9 and negative square root of negative 36?
You can simplify.
I can simplify them, though. Exactly. I got to simplify them down. What is the square root of negative 9? 3i. Excellent. So we get negative 2 plus 3i minus 1 minus what? What's the square root of negative 36? 6i. Not just 6. Be careful what you're saying here. You have a square root of a negative number. You have to first pull an I out. So we have 6i.
How'd you get 3i?
Because we can pull an I out. And then the square root of 9 is 3. So now we can combine like terms. Negative 2 minus 1, negative 3. 3i minus 6i, negative 3i. Okay? Questions? No? You sure?
So basically you're just simplifying numbers and then combining like terms?
That's what it comes down to. Yep. I'll show you one more example where there's a little bit more to it. Okay? Let's do that right now. In fact, we're not going to the back page, folks. We're staying on the front page. But if you look right above in your notes there, there's that kind of blank area. Let's put an extra example right there. All right. So, let's say in this example we have 2 times 1 plus 3i, and let's say we have plus 2i times 2 minus 4i. Okay? So, looking at the first set of parentheses, are those parentheses doing something for us? Yes, they're showing multiplication. We've got to take 2 times that complex number. That implies we have to distribute. Okay, so 2 times 1 is 2. 2 times 3i, 6i, exactly. Okay, so now look at the second set of parentheses. All right, we also have to distribute there, right? Now here you got to be careful though. So we're going to take 2i times 2, which is 4i. And we have to take 2i times a negative 4i. Negative 8i squared. I times I is I squared, just like x times x is x squared. So we have minus 8i squared. Okay, well here's one more thing that we got to pay attention to. I have it written on the board here. I'll write it up here as well.
I squared negative 1.
That's exactly it. I squared equals negative 1. Remember, I equals the square root of negative 1. And so I squared equals negative 1. So this right here, negative 8 times I squared is really negative 8 times negative 1, which is what? Positive 8. So we have 2 plus 6i plus 4i plus 8. Watch out for that, okay? And now at this stage, we just combine like terms. Are there any questions on that? Are you sure?